Hello everyone, welcome to the code space. In this video, we are going to see the hardware synchronization mechanisms that are used to obtain synchronization in among the processes. In the last OS class, we have discussed about the software synchronization algorithms, which are correct solutions, which we have discussed about Peterson's algorithm and Delco's algorithm, and we have successfully completed these software mechanisms to obtain synchronization among the processes. So basically the synchronization can be done using software methods. In the first class we have discussed about this hardware and as well as using some threads like semaphores, monitors, etc. In software we have learned about the lock variable, strict alternation, and Decker's algorithm along with Pearson's algorithm, among which only the Decker's algorithm and the Peters solution was the complete solutions. And today we're going to start the hardware synchronizations. In hardware synchronization methods, we have only two ways: TSL, TSL using TSL, and other one is using swap. Let us understand what is this TSL first. TSL is a hardware tool which performs a complete action in an atomic time. Like the action of TSL is to return the TSL is a function which takes the lock variable as argument and returns the state of the lock variable and assigns lock variable to true every time. Every time it alters the value of the lock variable to true. If it is already true, then it will set to true, and if it is false, then it will change it to true. It returns the current state as it is, which has given to this function, and it will then change the value of this lock variable to true. The key points is about this TSL is performs the above task atomically, which means it uh, these two actions will be performed together. The CPU or the process can't be preempted in between these processes. These two, if they decided to perform this, if the function call happens, TCL function call happens, then the entire action of the TCL will be performed atomically at a time. So we're going to use this TCL function to obtain synchronization. First, let us say a process one is in the ready queue, which is interested to participate in the critical section. The process one is interested to participate in the critical section. Then The algorithm works as follows. Like we'll have here the non-critical section of the process, and we'll run a while loop in which we'll call the TCL function. We'll use this TCL function, will TSL function, will pass the log variable as a reference. Initially, we have a log variable with default value as false. Let us initialize the log variable here in log or bool log equals false, and we'll pass the log variable as a reference so that the changes made in the TSL function should reflect in this main function also. I know you know the concept. I hope you know the concept of passing by reference and passing by value. And we'll execute the critical section of that process here. And in the exit section, we'll make the log value to false. So in this way, the synchronization is obtained using TSL. Let me write the TSL function also. TSL function will return a pool value, pool TSL, and it will take a pointer of this log variable. Now here we'll create a variable pool return val something which stores the current status of the log variable and assigns the value of this log variable to true. And finally, it will return the value of that log. So in this way, we'll implement the TCL. Let us check for the mutual exclusion and progress along with the bounded waiting. So if we see here, we can clearly say that mutual exclusion is guaranteed because we can't preempt the process in between those two steps, like changing the log value. We can't preempt in between because this part is going to be executed entirely by using some hardware tool, which makes us unable to preempt in between. So if a process, when the log variable is false and a process is entered into the critical section, immediately the entering of the process and changing the log variable to true will happen as an entire unit. So we can't preem in between, which simply guarantees mutual exclusion is guaranteed. Let's see for the progress. Here we can see that a process is independent on the interest of other process in the critical section. There is no dependency of a process in the other process. So progress is also guaranteed. Let us check for the boundedness. So let's suppose a process P1 has completed its critical section and put assign the value, change the value of the log to false. And if he wants to go into the critical section again, then there is no restriction for him. It can simply enter into the critical section again. There is no restriction which is stopping the process P1 from entering the critical section again, simply guarantees that, which simply implies that bounded waiting is not guaranteed. Is not guaranteed. So, in this way, we have successfully able to make sure that mutual exclusion and the progress is guaranteed but bounded. We are unable to make the boundedness. So, we'll apply some additional methods, additional futures or additional to make it guarantee the boundedness. So the next algorithm is swap mechanism. So in this method also we'll use some hardware tool which simply takes two variables as an argument and swap their values. So to make the changes of the variables reflect in the main function, we're going to pass these two variables as a reference. So we'll create a function swap which takes simply two variables, lock and key, and swaps those two variables. We'll create a temporary variable bool temp and we'll store the value of key. We can also store the value of lock, and key value of the key is assigned to the value of lock, and value of the lock is assigned to value of temp, which is nothing but indirectly the value of the key. So simply the both values are got swapped. In this way we use implement the swap function which simply swaps two values of two variables. So let's write the algorithm by which by using this swap will obtain the synchronization. So first we'll initialize a bool variable key with false and run a while loop. Here the process executes its non-critical section and will write the condition where it enters into the waiting state, and until the key value of the key remains 2, we will keep on swapping the values of the key and lock. We'll just keep on swapping those values of key and lock. Since we have created the pointers, we're going to pass the references of these variables so that the changes will reflect in this function also. The moment the value of key becomes false, which is actually obtained by if the value of the log is false and the swap operation is performed on both of these variables, then the value of key will become false and the loop terminates and enters into the critical section. And once it completes all its programs which related to the critical section, it will make the lock variable to false. Let us check for the conditions of mutual exclusion, whether the swap mechanism guarantees mutual exclusion or not. Let's suppose a process entered in the critical section. The moment it enters into the critical section, as we said that the swap mechanism is going to be performed as an entirely atomically as an entire unit, there is like the moment a process enters, the lock variable will be get changed, like the value of the lock variable will be get swapped with this key variable, and the moment the lock variable is assigned to false, by applying a swap operation, the key value will also become false, terminates this while loop, and starts executing the critical section. And again, the lock variable is set to the false. So here, the changing of key value to false and the lock value to 1 is happening in as an entire unit, which makes the processes, like which makes multiple processes to enter into the critical section, which means that it restricts multiple processes to enter into the critical section, as the lock variable is changing the moment a process enter into the critical section. The lock variable is changing to 1. It means mutual exclusion is guaranteed. Let's check for the progress. Here we can clearly see that execution of a process is completely independent, and it is not depending upon the interest of another process. It means that progress is guaranteed. Let us check for the bounded waiting. Here, let's suppose a process 1 is just completed its critical section and set assign the value of lock variable to false, and again it wants to go to into the critical section. We can clearly see that there is no restriction for this process to enter again into the critical section, which means that bounded waiting is also the bounded waiting is not guaranteed. So clearly we can say that swap mechanism is also not a complete solution, but we can still make but still can be obtained by using additional techniques, additional features or techniques. So in this way, we'll use this hardware techniques or hardware components to obtain the synchronization among the processes. This is all about the swap and TCL mechanisms, which are completely based on the software, like which are based on the software, hardware tools. In the next class, we are going to discuss about the synchronization using the threads and semaphores. I hope you like this video, and if you like this video, please hit the like button and subscribe to our channel. Thank you for watching.